All right, we're going to start with Chapter 6, Problem 9. I mean, conceptually, now that we've done the first couple problems in Chapter 6, this one could even be easier than what we did before. But conceptually, it might be a little more abstract. There's less words, less numbers, but you're going to do them almost the exact same way. So let's get into it. Scott & Associates, Inc. is an accounting firm that has 3 new clients. Project leaders will be assigned to the 3 clients. Based on the different backgrounds and experiences of the leaders, the various leader-client assignments differ in terms of projected completion times. The possible assignments and the estimated completion times in days are as follows. Develop a network representation of this problem. That's your model. And B, formulate the problem as a linear program and solve. What is the total time required for the assignment? So what this would be is like if client 1 and Jackson work together, it's going to take 10 hours. But if client 1 and Ellis work together, it'll take 14 because they're not going to work as well together. So what they want to do is optimize the working relationships. And at first you say, well, I could just figure that out in my head. But the more you look into it, the more difficult it is. Because everybody works best with Jackson, right? So which one do you actually give to Jackson? And people work the second best. Well, some people work the second best with Ellis and some with Smith. So it is a little bit tricky. And so you can develop a very simple model to get this done. All right, now here's where I'm going to be lazy, but you guys can't be. Since I've already done it once, I don't want to enter everything in again. So I'm going to cut and paste what I already did. And you guys get to put that in now. Now this is straight from, that's that matrix right there in problem 9 in the book.
How do you know everybody works better with Jackson?
Because client 1 would take 10 hours with Jackson, 14 with Ellis, and 22 with Smith.
Yeah.
Okay, you get it now?
I thought it was Max.
Yeah.
Need clarification.
It's like a reasonable temperature in here today. Is it still nice out or is it warming up?
It's in your warm forecast over the next few days.
I saw in the long, like the 10-day forecast that at like the middle of next week, or a week from now, next Thursday is supposed to be a high of 70.
Let's go.
Glorious. Let's go.
Doesn't that sound nice?
That's what we need.
Yeah.
So happy.
I'll tell you, yesterday morning, was it yesterday or the day before, it was cold. I mean, compared to what, I mean, when I went outside, it was like 53 degrees in the morning. It was nice. I left the window open in my bedroom, and because it'd been like lows of 68, and I left the window open. I was huddled in a little ball, shivering. I kind of enjoyed it. You kind of missed that. Instead of just like the dripping sweat. And my wife, she gets up before me to get the kids ready, and she's like waking me up. You're shivering. I know. Leave me alone. Okay, you guys good? You got this? All right, so now let's take, I'm going to do what I showed you the other day, just so I don't have to retype in some of this. I'm going to take it and cut and paste it, but I'm going to delete all of this in here. Now, you're probably thinking about why didn't I sum those other columns? Because we don't need to on this kind of problem. It's actually a little more straightforward. Because we don't really have constraints given to us. We're going to come up with constraints, but none are given to us. All we want to know is how do we optimize that chart? All right, so we all good? Okay, let's yellow out these cells here, just like we did the other day. And now what we're going to do, and this will be a little abstract, but I'll explain it, is we need to total. We're going to have total down here and a total here. So just go with me right now. We're going to total this horizontally. So do an auto sum, or you can do it manually. Sum those 3 cells and drag them down. And we're going to do the same over here with the 3 above it. Drag them over. I'll let you guys catch up. Who wasn't here Tuesday? Did you get a chance to look at the video? Okay. If you take a peek, I lay a lot of the groundwork for this type of problem on there. I think it's only like 11 or 12 minutes or something. And that'll help you with problem 5, and you'll get this. I mean, you don't need to have heard that to understand this, but it'll be helpful. Okay, so once you've got this, we're going to do the same less than or equal to signs. Drag those down just like the other problems. And over here, we're going to do equals, just like we did on the other problems, and drag those over. Now, this is going to seem a little weird, but go with me and then I'll explain it in a minute. Once you get those signs, we're just going to put the number 1 in here. And we're going to do the same up here. So go ahead and do that. All right, and then we're going to do total cost. Because remember, that's what we're doing, is we're trying to minimize our cost. And we're going to paint that cell red. And then we're going to do a sum product, just like we did the other day. Sum product, open parentheses, highlight these 9 cells, comma, these 9. You didn't get to see this. Can you see what I did?
Mm-hmm.
Okay. All right. Now we can go into Solver and solve it right now. You guys know how to set that up, but I want to explain why we're doing what we're doing. And when you choose, when you make a choice in terms of what goes into the yellow cell, will obviously be a 1 or a 0 into every cell, correct? Because it has to, each column up and down, 1, 2, and 3 for the different clients can only have one in it, right? Because they're it has to total to no more or no less than 1, exactly 1. And going horizontally, once again, each Ellis, Smith, and Jackson can only be used once. What this does is it assures that each client and each project leader can only be selected once. So it's a 1-to-1 relationship. So that's how we're setting it up. And then those 1s will be multiplied by the time taken up above, and that will be all summed together. And since we're telling the computer to minimize it, it's going to pick the best possible connections to give us the lowest possible sum. You guys track with that? Okay. So we're going to, I got to hit enter here. Let's go to solver, data. Where's my solver?
It's right there.
It is?
Isn't it? Right. It doesn't say solver. Question mark with the arrow.
Yeah.
Isn't that solver? That's it.
You.
Oh, you need a.
Oh, you still have the cell selected.
Yeah.
Oh,
You have to
okay.
do
I messed it all up. Data. What happened?
It's the question mark with the arrow.
Huh. Okay. Must be the different screen widths that I use. Okay, so we've got set objective cell is to the red. We're minimizing cost, changing the yellow cells, as always. We're going to just set this up like we did the other day, set it up to linear, add your constraints. We'll do those 3 are equal to these 3. Add, and then these 3 less than or equal to these 3. Okay. Constraint must be a number. Okay, what did I do wrong? G10 to G12. Huh. Oh, I get it. Alright, I was going too fast, messed myself up. We hit solve. and we get 64. 64, 64, 64s throughout. Okay. Everybody, so we're good with that. So what this has told us is that client 1 is going to go with Ellis, client 2 is going with Jackson, and client 3 is going with Smith. So that's the answer. I mean, and you know how many total hours it's going to take. You probably could have done that. If I told you to figure it out from that chart, you probably could have trial and errored it and figured it out. But once the chart gets bigger, like we're going to do in a minute, that doesn't become practical any longer. So this kind of making sense in what we did, what we're doing? Okay. Now, not everything may always be ones on the side. They may say select more than one. And I'm going to show you one other thing in Solver that may be needed at times. Is I'm going to add one more, and I'm going to select all of these. And I'm going to constrain them to be integers. Because what could have happened on this is it could have put half of a client with one person and half with another. It didn't work out that way, but it could have done it because you said it has to be equal to 1. Well, I guess it is equal to 1 going up. Well, the total has to be equal to 1. So it could have put 0.5 here, 0.5 there, 0.75, 0.25. So if you set it to integers, remember integers from like the 7th grade? Only whole numbers. Right. So I'm going to set that to integer. And you will need to know how to do that, and then you just click OK. And this will happen on future. And you guys thought you would never need to know this stuff after the 7th grade. Okay, it's the same answer because it worked out. But to be safe, if you're doing something like this, it's usually, and you don't want parts of numbers, you'll need to set it to integer. Or if you solve it and it comes out partials, you can then go back and add the integer constraint. So be aware of that. We good with this one? All right. I'm going to stop the